Hello everyone, I am Chris. Welcome to this channel. In our increasingly digital world, convenience is king. We shop online, bank from our phones, and manage our lives with a few taps. But this digital ecosystem has a shadow, a multi-trillion-dollar shadow called fraud. Every time you make a transaction, a silent battle is waged in milliseconds. On one side, criminals using sophisticated bots, stolen identities, and social engineering. On the other, the defenders, the systems designed to protect our assets and data. For decades, these defenses relied on rigid rules. If a transaction is over $500, flag it. If it's from a foreign country, block it. But the fraudsters learned. They adapted. They found the cracks. This is where the game has changed. Today, we will explore the revolutionary force that is turning the tide in this battle. Artificial intelligence. Let's first understand the enemy. Global fraud losses are staggering, measured in trillions of dollars annually. It's not just about financial loss, it's about eroded trust. When a customer is defrauded, they don't just lose money, they lose faith in the brand they trusted. Traditional, rule-based systems are like a high wall with a single gate. They are excellent at stopping the obvious attacks. But they create two major problems. First, false positives. A legitimate customer traveling abroad gets their card blocked for buying a coffee. This leads to frustration, costly customer service calls, and abandoned carts. Second, false negatives. A clever fraudster, using stolen details that perfectly mimic normal behavior, slips through the gates undetected. The fundamental flaw of these systems is that they are reactive. They can only stop what we already know to be fraud. They cannot see the new, emerging patterns. They cannot learn. Artificial intelligence changes this paradigm from reactive to proactive and predictive. So, how does AI actually detect fraud? It's not a single magic box, but a powerful toolkit. The most critical tool is machine learning, or ML. Think of machine learning as teaching a computer to recognize fraud by showing it millions of examples. You feed it historical data, millions of transactions, both legitimate and fraudulent. The algorithm doesn't get a simple rule. Instead, it finds complex, hidden patterns and correlations within that data that are invisible to the human eye. For instance, a rule-based system might see transaction from New York for $200. Approved. A machine learning model might see user login from New York, but the device ID is new, the typing speed is slightly different from the user's average, and the purchase is for a product category the user never buys, even though the amount is small. Risk score, 85%. This ability to analyze hundreds of data points in real time is the core of AI's power. Let's dive into two specific types of machine learning that are superstars in fraud detection. First, supervised learning. This is the most common approach. Here, we train the model with labeled data. That means every transaction in the training set is tagged as either fraud or not fraud. The model learns the signatures of both. It's like a detective studying thousands of solved cases to understand the modus operandi of criminals. Supervised learning models are excellent at classifying new transactions based on what they've learned from the past. Second, and increasingly important, is unsupervised learning. This is even more powerful because it doesn't need labeled data. It simply analyzes all the data and looks for what's unusual. It looks for outliers, or anomalies. Imagine a crowded party where everyone is talking quietly. An unsupervised learning model would immediately flag the one person who suddenly starts shouting. It doesn't know why they're shouting, but it knows the behavior is anomalous. In practice, this means it can detect new types of fraud that have never been seen before. A fraud ring testing a new technique will create a subtle, unusual pattern in the data, and an unsupervised anomaly detection model can spot it. Beyond these, we have more advanced techniques. Deep learning, which uses complex neural networks, can find patterns within patterns, especially in unstructured data like email text, device fingerprints, or network logs. And then there's network analysis. Fraudsters rarely act alone. They operate in networks. AI can map the relationships between entities, users, accounts, devices, IP addresses, to uncover these hidden rings. For example, it can identify hundreds of seemingly unrelated accounts that all funnel money to the same destination, or that were all created from the same cluster of devices. A human analyst could never connect these dots across millions of data points, but I can visualize this criminal network in seconds. Let's move from theory to practice. Where is this AI-powered fraud detection making a difference? In banking and credit, this is now table stakes. AI models analyze your spending habits in real time. If a transaction doesn't fit your profile, like a sudden large purchase in a different country, the system can decline it instantly or send a verification push to your phone, often before you even get a fraud alert from your bank. In e-commerce, AI fights against payment fraud, account takeover, and friendly fraud. It can assess the risk of a transaction by analyzing the buyer's behavior, the shipping address, the device used, and even the time spent on the checkout page. This directly reduces false declines, meaning more legitimate sales go through. In the insurance industry, AI is used to combat fraudulent claims. It can analyze the text of a claim, cross-reference it with historical data, and flag claims that have suspicious similarities to known fraudulent patterns. And in telecommunications, AI helps prevent SIM swap attacks and the fraudulent opening of new accounts, saving companies billions. The benefits are transformative. Companies using AI see a dramatic reduction in fraud losses, sometimes by double-digit percentages. But the wins go further. Customer experience improves drastically because of the reduction in false positives. Legitimate transactions are no longer unnecessarily blocked. Operational efficiency soars as AI automates the initial screening of thousands of transactions, allowing human investigators to focus only on the most complex, high-risk cases that the AI flags for review. It creates a powerful feedback loop. Every decision the AI makes, whether confirmed or overturned by a human investigator, becomes new data, making the model smarter and more accurate over time. The picture I've painted is impressive, but it's not without its challenges. Implementing AI is not simply plugging in software. First, there's the issue of data. AI models are hungry. They require vast amounts of high-quality, clean, and well-labeled data to train effectively. A company with siloed or messy data will struggle. Second, there is the black box problem. Some of the most complex AI models, especially deep learning networks, can be difficult to interpret. It can be hard to explain exactly why a transaction was declined. This creates challenges for regulators and for customer trust. The field of explainable AI, or XAI, is rapidly evolving to solve this, creating models that can justify their decisions in human understandable terms. Third, there is the arms race. Fraudsters are now starting to use AI themselves, a concept known as adversarial AI. They can use machine learning to probe defenses, generate fake profiles, or create sophisticated phishing emails. The battle is escalating. This leads to the most important point. AI does not replace humans. The goal is not a fully autonomous system, but a perfect partnership. AI is the hyper-alert, infinitely scalable sentry. It monitors everything, all the time. It identifies the potential threats from the ocean of data. The human investigator is the expert detective. They bring context, intuition, and ethical judgment that AI lacks. They handle the complex investigations, make the final judgment calls, and provide the feedback that makes the AI smarter. The future of fraud detection is a human-in-the-loop system, where AI handles the volume and scale, and humans handle the nuance and strategy. So, what does the future hold? The technology will only get more sophisticated. We will see more generative AI used to create synthetic, but realistic, fraud data to train models without compromising real customer data. Behavioral biometrics will analyze how a user holds their phone, their typing rhythm, and their mouse movements to create a unique, unforgeable signature. AI will become more contextual, understanding not just the transaction but the entire user journey. and explainable. AI will become the standard, building the transparency needed for widespread trust and regulatory approval. In conclusion, the fight against fraud is a perpetual one. But with artificial intelligence, we have a powerful new ally. It is shifting the balance of power from the fraudster to the defender. It is moving us from a world of reactive rules to a world of proactive, intelligent protection. By leveraging machine learning, anomaly detection, and network analysis, we are not just building higher walls. We are creating intelligent guardians that learn, adapt, and predict. The goal is a digital economy that is not only convenient, but fundamentally secure and trustworthy for everyone. Thank you for your attention. That's to the end of this sharing. Hope to see you again. Goodbye. Hello, everyone.